And so what else can we do with the model? Because the Markov model of tangent dynamics has 9 free parameters, and so far we have only used one of them, which is beta 7. So presumably there are a lot of dynamics that can be captured by the other 8 free parameters, right? So and we did not stop over there, because in terms of choice strategy or processing strategy, we can also get insights of choice strategy from behavior data, which is binary choice data, and this can we can do this based on our behavior models, right? So recall that among all the behavior models, we can categorize them into 2 categories. One is discounting, the other is interval. The other is time as attribute models, and we can make a comparison with these 2 models to see, are people making option-wise evaluation or attribute evaluation. So suppose people are making attribute-wise evaluation, then the time as attribute models are likely to jump up as the better performing model. And suppose people are using option-wise evaluation, then maybe participants are likely to the data is likely to be better described by discounting models, right? So we can use such comparative model fits to extract the choice strategies that the subjects are applying in their choice. And we can also make a formal link between this and what we get from the Payne index, model-based Payne index. And first off, let's take a look what the model fits looks like. So basically, we have applied a total of 18 intertemperature choice models, including 13 discounting models and 5 time as attribute models. And then we correlate each pair of these models to see how similar they are in terms of accounting for individual fits. And we found the correlation. This is the correlation matrix of these 18 models in each of the conditions. And as you can see, the discounting models are pretty similar to each other. As you can see, those, for example, this corner over here, and the time as attribute models, they are sort of similar to each other too, although there are some models that do not resemble others. But when we take a look at this the attribute, time as attribute and discounting correlation, they are much lower than the within category correlations. This resembles a lot with the model space results that discounting models are similar, and time as attribute models are dissimilar, and within time as attribute models there are some outliers, etc., etc. And this also sort of validates the comparative model fits as a valid metric for identifying choice strategy, right? And then we made comparisons between different models on the individual level to get a comparative model fits. And make a link to the Payne index, the model-based Payne index we identified from our Markov model of attention dynamics, and we can correlate the two. And we find that across conditions and in the pooled analysis, there's a significant correlation between the two. And the correlation coefficient is close to 0.2 or 0.3, depending on what error specification you use. We tried two error specifications. One is the logit, the other is a loose for the behavior choice model. To wrap up, so first off, in the paper, we outline why intertemporal choice modeling requires interdependent processing of amount of time. And then we advanced a Markov model of attention dynamics to estimate interdependence at the individual level from eye tracking data. And we also show that the model can also capture rich features of the processing dynamics that directly links to the choice strategies that we can extract from behavior data by using the behavior choice models. That's all about the talk. Thank you.